In this video, we'll see a derivation of expression for electric field due to a dipole along the equatorial line of the dipole. Okay, and I hope you'll be clear with the previous derivation, that is along the axial point, dipole along the axial point. Okay, and the same step we'll use here, but there will be a slight changes in the steps. That's it. And if you're clear with it, it will be more easy with this derivation. Okay, for that first we have to consider two charges, that is dipole, positive charge and negative charge, and the distance between them is 2a, and charge, positive charge distance from center is a, and negative charge distance from center is also a. And this is the equatorial line which is passing through the center and the axial line, right? And they are saying dipole along the equatorial line. Okay, along the equatorial line we'll consider a point whose distance from the center is r. Okay, and the same step, the electric field due to plus q and electric field due to minus q we have to know here. So I'll place a unit positive charge here. Okay, so electric field due to q here will be in away from q, right? Away from q, it is in this direction. Okay, this is electric field due to positive q, and next is electric field due to negative q. Okay, so electric field due to negative q. See, I am placing a positive charge here. This is a negative charge, so they attract. This is the electric field due to negative q. Okay, and next is, this can be resolved into two components. Okay, a vertical component and a horizontal component, right? So E plus Q makes an angle theta with the horizontal component, that is x-axis. Okay, and this is E plus Q cos theta, and this will be E plus Q sin theta, right? And also this makes an angle theta, right? This also makes an angle. E minus Q also makes an angle theta with the horizontal component. So there will be E minus Q cos theta along the x-axis and downward along the y-axis, E minus Q sin theta. Okay, as we can observe, this E minus Q sin theta and E plus Q sin theta are equal and opposite in the direction, right? So they are equal in magnitude but opposite in direction, so they cancel out on each other, and the total electric field at the point P is just because of the E plus Q cos theta and E minus Q cos theta, and sin theta will get cancelled. Okay, we'll just join this point P and Q. Okay, after joining it, the positive Q, this line makes an angle theta with the axial line. Okay, the diagram only is this much. The diagram is only this much. And now we'll start with the derivations. Okay. So the first one is the electric field, right? Electric field are obtained. Okay, electric field at any point is obtained by using parallelogram law of vector addition. Okay, parallelogram law of vector addition. Okay, next is the electric field, the same step, electric field due to positive charge, that is 1 by 4 pi epsilon naught q by. So what is the distance of positive q from P? Okay, so for this we'll consider right angle triangle POQ. Okay, POQ. Let me just take a Q only. Okay, so hypotenuse square is equal to opposite side square plus adjacent side square, right? We know this. Okay, this is the hypotenuse. So hypotenuse will just take as it is. Adjacent side, opposite side is r square plus and adjacent side is a square. So the distance is hypotenuse is equal to root of r square plus a square. Okay, this is the distance of positive charge and distance between positive charge and P and negative charge and P. Okay, we'll just write it here as the distance is root r square plus a square, and here is also root r square plus a square. Okay, and we'll substitute the value r square, right? R square plus a square the whole square. This root and square root cancel. So electric field due to positive charge is 1 by 4 pi epsilon naught q by r square plus a square. Okay, the same will be for the negative charge. 1 by 4 pi epsilon naught, here charge is negative charge minus q, so root of r square plus a square the whole square, which is equal to 1 by 4 pi epsilon naught minus q by r square plus a square, right? So now is theta, cos theta is adjacent by hypotenuse, right? Adjacent is a and hypotenuse is root r square plus a square. So, and E of plus Q is Q by R square plus A square 1 by 4 pi epsilon naught. Cos theta is A by root of R square plus A square.
And here we are considering positive q. This is because e plus q cos theta and e minus q cos theta are in same direction.
Q by R square plus A square by 1 by 4 epsilon naught into A by R square root of R square plus A square. Okay, on adding this we'll get 2Q by 4 pi epsilon naught R square plus A square into A by root of R square plus A square, and P cap. P cap is a unit vector. We have already seen it. Okay, and the next one is at large distances R will be much greater than A, right? Okay, at large distances R is much greater than A. So therefore equation will reduce to this R square plus A square is there, no, that will become this A square we are just neglecting, sorry, the A square is neglected. Okay, the A square we are just neglecting. What we are going to do is, we have got E is equal to minus 2g by 4 pi epsilon naught r square plus a square, r square plus a square into a by root of r square plus a square, right? They are just removing out this a square because a square will be much lesser than r square, right? So on removing it, E is equal to minus 2QA by 4 pi epsilon naught, r square remains the same, and this, if A root A, we can write as A power 1 by 2. Okay, this is the power of root. Okay, so if A square is removed, R square into 1 by 2. Here E is equal to minus 2QA by 4 pi epsilon naught R square. Okay, R square will get cancelled, right? So this 2 can cancel. So R square into R is R cube, right? So E is equal to minus 2QA by 4 pi epsilon naught R cube we have got. We know that dipole moment is the product of magnitude of either one of the charge and the distance between them. So E is equal to Q2A. Q2A is same, minus P divided by 4 pi epsilon naught R cube. So E is equal to minus 1 by 4 pi epsilon naught P by R cube. This is the equation for the electric field due to a dipole along the equatorial line of the dipole. Okay.